All right, so what we're looking at here now is we're back into, well, we've been doing Newton's laws, but we're going to look at Newton laws in a certain situation when that involves ropes and pulleys. And so I'm going to do examples 2, 3, and 4 from the note. And so I start off with example 2, where we have two masses here on a frictionless pulley. And what we're going to try to determine is what force are the ropes pulling up. They're both pulling up on both objects here. And also, what is the acceleration of both of these masses? Now, this mass here, our first one, is a 4 kilogram mass. I'll put a 1 there. That's our first one. And our second mass is 7.4. All right, now I'm going to call that object 2. So what we again want to figure out is, what are the ropes pulling on these masses with, and how fast are they moving, and which direction they're moving? Now, a key thing in this example is I think it's kind of obvious that if you attach these two masses, well, the 7.4 kilogram mass is going to win. It's going to go down. The 4 kilogram mass is going to go up. Now, because of that, I'm going to note here that if I look at object 1 here, its acceleration, they're going to be equal because they're moving at the same rate. If one's going up, one's going down, they're going to move at the same rate, but opposite directions. So my A1 is equal to A2. All right, negative A2, because they're in the opposite directions, but yet equal in magnitude. All right, now, here's what we're going to do, is I'm going to look at each object first, individually. So I have my 4 kilogram mass. Now, on that mass, we have two forces acting on it. We have the rope pulling it up. And that force of pulling it up, we call T, the tension in the string. All right, now, on the second mass, it's the same string pulling up with the same amount of tension. But we'll get to that. Now, the other force, because it's just hanging freely, is the force of gravity is working on this 4 kilogram mass. And I can actually find that mass because I know Fg is equal to mass times acceleration. And so in this case, we're going to have a 4 times a 9.8. And if that's a round number, I think it is. Let's see here. Nope. 39.2 newtons. All right, and that is the force of gravity. Now, what I'm going to do is look at this first mass, and I'm going to come up with an equation to talk about this mass. And the first thing is I'm going to use Newton's second law that says F net is equal to M. I should put MA, but I'm going to put M1A1. Because we have two objects, I better notation-wise explain that. Now, that net force on this object is we have a T pulling up, positive T here, and the force of gravity pulling down. So I'm going to have a negative 39.2. All right, now I can further substitute because I do know M1 here. I do know the mass of object 1 is 4. And so I have a 4A1 is equal to T minus 39.2. Now I'm going to make one more adjustment to this equation. I'm going to move this minus 39.2 over to the other side. You will see shortly why I'm doing that. And so when I move it to the other side, it's going to become a positive 39.2. And that is equal to T. That is the equation for object number 1. All right, so I've got something there. And now I can't find T or find A1 because I have one equation, 2 unknowns. I can't do it. All right, so now I'm going to go to my second object. All right, now my second object, I'm going to look at it in a very similar manner in that it is a 7.4 kilogram mass. And there is 2 forces acting on it as well. The tension is pulling it up, and the force of gravity is bringing it down. All right, and so again, I could find that force of gravity by taking my mass, 7.4, and timesing it by G, 9.8. And this time I would get 72.52. All right, so now I'm going to come up with an equation for my second object. And again, F net is equal to MA, or in this case, M2A2. All right, so there's my net forces are equal to M2A2. And what forces do I have? Well, again, I have the T pulling up and the force of gravity pulling down. So it's going to be a minus sign, minus 72.52. Now I have another equation here. This time I'm going to make two adjustments. All right, now the first adjustment, hold on, better back it up here. I have my mass. I'm going to put that in first before I get making my adjustments here. Don't jump the gun here. Because here is the key first adjustment. In this equation, I have an A1 and a T. In this equation, I have an A2 and a T. I'm going to end up using a little grade 10 math coming here where I'm going to use solving systems of equations. So what I want is two equations, but only two unknowns. Right now I got three of them. I have an A1, an A2, and a T. But I can eliminate this A2 because A2 is A1, or A1 is equal to -2. They're the opposites. Another thing you could say is negative A1 is equal to A2. It's another way of saying they're just the opposites. So instead of an A2 over there, I'm going to put a negative A1. So this is going to become negative 7.4 A1 is equal to T minus 72.52. So again, all I did was replace the A2 with a negative A1 because of the opposites. One goes up, one goes down. The second adjustment I'm going to make with that formula is the same as the one I did on the first equation. I'm going to move the negative 72.52 over to get T by itself. All right, so I have a negative 7.4 A1 plus 72.52 equals my T. All right, that is my second equation. Now, here's what I've got. I've got two equations with two unknowns, A1 and T. All right, so what I'm going to do is a little solving by substitution. Now, it's a simple substitution, which sometimes confuses people. But here's how I'm going to do it, is that if T is equal to this and T is equal to this, then they must be equal to each other. So therefore, what was T equal to here? 4A1 plus 39.2, which was equal to T. Well, what else is equal to T? My second equation, a negative 7.4A1 plus the 72.52. So I make them two equal to each other because they're both equal to T. And now what I have is one equation, one unknown, which means I can solve. All right, so I'm going to get my A1 terms on one side, numbers on the other. And so I have a 4A1 here. I'm going to bring the negative 7.4A1 over, so it's going to become a positive 7A1. And then I have a 72.52 over there. All right, I'm now going to bring the negative 39.2 over to the other side, which then means it's going to be negative. All right, so now I'm just simplifying, negative 7.4A1. So it should be a positive 7.4A1. I put those together, the A1 terms, I'm going to get an 11.4A1. Let's see, I subtract those numbers. I don't know, I'm going to have to use my calculator here. And I end up with 33.32. All right, get A1 by itself. I'm going to divide both sides by 11.4. And it turns out my A1, my acceleration, is going to be 2.92 meters per second squared. All right. So what does that mean? Well, in terms of our diagram, this is our first object. It's a positive acceleration. Our 4 kilogram mass is going to go up. A2 is negative 9.92. Our bigger mass is going to go down, which we kind of knew, right? What's the other thing we wanted? Was the tension, the force that the string is pulling up or wire on both of them, because it's equal. Well, I have my A1 here. I have two formulas that I could use. I'm going to go with the first one here because there's no negative signs. So therefore, in this case, T is equal to, let's see, 4 times A1, which is just 4 times 2.92 plus, what else we got here? The 39.2. And if I 4 times 2.92, then I add 39.2, and it looks like the string is pulling up with 50.88 newtons. So now we know what direction these masses move, how fast they're accelerating, and what the force of the string is that's pulling on them. All right, so that's the second example. We're going to do the third one now. A little bit different, but setting it up is the same. All right, so let's see here. We get to all right, so example 2, what do we got here? Situation, or sorry, example 3. All right, so we have a mass on a table. All right, so I'll draw my table here first. There we go. Here's M1. All right, attached by a string. Here's my pulley. There we go. And so what we want to look at is which way do they move? Well, again, this situation might be, but how fast they move and how hard is the rope pulling? All right, so in this case, again, just drawing in the masses, this one is 14 kilograms, and this one here is 20 kilograms. Now, there's an extra added note here is that our mass that's on the table is not on a frictionless surface. So it actually has force of friction is 16 newtons. So we have a force of friction here going this way of 16 newtons. That's our force of friction. All right. Now, again, when I look at the situation here of these two masses, is that most likely our 14 is going to move to the right and our 20 is going to move down, which means, again, I'm going to call this my first object here, and this is my second, is that A1, again, is equal to negative A2. Or they're the opposite. You could say negative A1 is equal to A2 because one moves to the right and one moves down. They move in opposite directions. Or say for some magical reason they didn't, one would move left and the other would move up. Again, opposite directions. All right, so now I look at the diagram and what forces I have on here. Again, on our 14 kilogram mass, we have friction acting on it, and we also have tension. The rope is pulling on it, just like the rope is pulling on our 20 kilogram mass, so I'll put a T there. But our 20 kilogram mass is also hanging. So we have the force of gravity on it. Now, again, I could use M times G. So 20 times our 9.8. And in fact, I get 196 newtons. All right, so I've got my diagram drawn in there. So I'm going to come up with my two equations again. And again, solving the systems of equations. All right, so my first object. Again, my net force is equal to MA, or in this case, M1 times A1. Now, I have this tension force pulling to the right, but I have friction here pulling to the left, so I'm going to have a minus 16. I know the mass is 14. I don't know how it accelerates. And once again, I'm going to make an adjustment of this formula where I'm just going to get T by itself. So I'm going to move the negative 16 over to the other side. And so I get 14A1 plus 16 equals T. There's my first equation. All right. Now I go and look at my second equation, my second mass. Again, F net is equal to MA. But in this case, because I'm dealing with the second one, I'm going to go M2A2 is my net force. I have the forces. I'm looking at my free body diagram here. The tension is pulling up, but gravity is pulling down with 196 newtons. All right, once again, I'm going to substitute in here. My mass is 20. A2 equals T minus 196. All right, now again, this is the second equation. I'm always going to make two adjustments. The first one is the opposite here. Instead of an A2, I'm going to put in a negative A1 because they're opposite. So this is going to become negative 20A1 equals T minus 196. All right, so there's my first adjustment. My second adjustment, again, is getting T by itself. So I'm going to move the minus 196 to the other side. So I have minus 20A1 plus 196 is equal to T. There's my second equation. So as I mentioned, I'm down to two equations and two unknowns. I can solve this. And again, I use substitution, the simplest form of substitution. T equals this, T equals that. So these two guys are equal to each other. All right, so therefore, 14A1 plus 16 is equal to minus 20A1 plus 196. All right, and again, the reason we do substitution is because now I'm down to one equation, one unknown. All right, I'm going to move the minus 20A1 over to the other side, so that means it's going to become a positive 20A1. I'm going to move the 16 over to the other side, so it's actually going to be a minus 16. All right, so again, doing a little bit of math here. Let's see, put our A1 terms together. I get a 34A1. And, well, 196 minus 16, well, I know that is 180. All right, and lastly, to get my acceleration anyways, is that I'm going to divide both sides by 34. And it looks like my A1, that'll tell us what direction everything's moving in. Let's see here. I get 180 divided by 34. I'm getting 5.29 meters per second squared. So that, again, kind of obvious in this situation. Our first mass is moving to the right. And in the opposite direction here, A2 is negative. So our second mass is moving down. Now, the final step is let's find how much force the rope is supplying here. So again, I just have to pick one of my formulas. I'm again going to go with the first one because there's no negative signs. And in fact, the numbers are smaller. And so I've got T is equal to, let's see here, 14 times A1, 14 times 5.29 plus 16. All right. And I do a little bit of math here. Let's see, 14 times 4, 5.9. And then I add 16. And let's see here, I get 90.12 newtons. And there we go. All right. Last one, we'll go with an angle this time. All right, so we'll look at example 4. Where we have the same idea, just now one's on a slope. Okay, so all right, so last one. And so we have example 4. Okay, so we have our, make sure I get this right. There's our slope. All right, there is a 30-degree angle right here. So that's the slope. It's a right angle triangle. We have our 10-kilogram mass. Right there, it's attached to a pulley. Let's try to draw that first. All right, then we have this mass hanging there that is 30 kilograms. I'll call this object 1, and this one will be object 2. All right, so again, analyzing the forces that are acting on both objects. Well, again, tension is pulling up on this mass, and this one it's, well, also pulling up. Now, again, with our accelerations, A1 is equal to negative A2. They're the opposites. One's going up, one's going down. All right, again, or you can look at it as negative A1 equals negative A2 or positive A2. Okay, so now we look at the forces on these objects. All right, so again, we had our tension pulling up on both, right? The rope is pulling up on both. Now this 30 kilogram mass, we have the force of gravity again. It's just hanging by the rope. And so I find it by, again, finding mass times G, 9.8. And let's see here. I do that, and I get 294 newtons. Okay. All right, now, here's where things get a little bit tricky, is I have my mass on the slope. Now, T is pulling it up. But the thing is, on this slope, is gravity is also working on this slope. And again, what's happening here, this is tough to see, is we have gravity acting down, and Fg is equal to mass times acceleration. It is 98 newtons. Now, that is not what's acting down on our block. We have a component of gravity that's acting down the block. So there is a component of gravity that is keeping the block on the slope. That's not the one we want. We want this component of gravity right there, Fd, the component of gravity that is forcing the block down the slope. So there's a component of gravity that's keeping the block on the slope, and there's a component that is forcing it down the slope. And that's the one we want. That's our Fd. And again, a little trigonometry. If I have a 30-degree angle in here, there is a 30-degree angle right here. All right, and so when we have our hypotenuse here, it's 98 newtons. And so we're looking for the opposite. All right, and we have the hypotenuse, and so our Fd is going to be 98. It's the opposite, right? So it's going to be times sine 30 degrees. And so that force of gravity, that component of gravity, that is bringing that 10 kilogram mass down the slope is 98 times sine 30 degrees, just a little bit of trig. And I end up, a flat number there, 49 newtons. All right. And again, that's because we have sine 30 degrees is equal to Fd, which is the opposite, divided by our hypotenuse, which was the 98 newtons. So I just rearranged that formula there. All right, so now that I've got all my forces made out, I'm going to just repeat the process that I did before, come up with my two equations, and then solve by using substitution, systems of equations here. So, object one, F net is equal to MA, or in this case, M1A1. T, pulling up. Gravity, pulling down. So it's going to be a minus 294. All right, I know the mass is 30, so I'm going to throw that in there. So we have 30A1 is equal to T minus 294. All right, and again, I'm going to make one adjustment to this formula, 2 for the other one. I'm going to move the minus 294 over to the other side, and so I end up with positive 294 is equal to T. So there's my first equation. All right, and of course, I'm going to come up with my second equation. Again, using F net equals MA, or M2A2. All right, now what do we have here? I know it's a little bit crazy. We have T is pulling it up the slope, but a component of gravity, Fd, I call it down the slope, so that's a minus 49. All right, mass. I know it is a 10 kilogram object, so 10 times A2 equals T minus 49. All right, so now here's when I make my two adjustments. The first one is I know my accelerations are the opposite. And so instead of an A2, I put in a negative A1, which means I'm going to have a negative 10 A1 instead of a 10 A2. And then T minus 49. And then, of course, my second adjustment is to bring that minus 49 over to the other side. And so I have minus 10 A1 plus 49 equals T. All right. So there's my two equations. So now I'm doing the solving systems of equations because I've got two equations, two unknowns. T equals this, T equals that, which means they equal each other. So I have a 30A1 plus 294 equals negative 10A1 plus 49. All right, let's get our A1s to one side, numbers on the other. And so I get on this side, I'm going to have a 30A1 plus a 10A1. All right, there's a 49 on this side. And we have a minus 294 on the other. This is coming to the other side. So I got a 40A1 here. And, minus here. So 49 minus 294. I don't know that. Minus 196. All right. I'm going to divide both sides by 40. And I end up with A1 is equal to, it's going to be negative. And I end up with negative 4.9 meters per second squared. So that's telling me this mass is going down. It's negative. It's the first time we had an acceleration that was negative. This one's going down. Well, the 10 one's going up. Makes sense. All right. And then the last thing is going to substitute into one of our equations to find the tension in the rope, the force supplied by the rope. Again, I always like to use the one with no negative signs or smaller numbers. And so I make a substitution. I've got T equals, let me see, 30 times A1. Well, that means 30 times negative 4.9. And then plus 294. All right, and I find out 30 times negative 4.9. Let's see here. 30. Whoa, clear. 30 times negative 4.9. And then we add our 294. I'm getting a nice round number here. 147 newtons.
I have a question.
There we go. Yeah, go ahead.
When you I don't know how to say it, but the 49 minus 294, is that what it gives you negative 196?
Yeah, negative 196. Because the 49 over here was positive, and when I moved the 294 over, it became negative.
Okay.
And so when I get a negative A1, when I look at my diagram, that just means the 30 is going down. That's our first mass, which it looks like it's gonna, right? Like if you got a 30 kilogram mass, you got a 10. Doesn't always work out that way, but in this case it did because the weight is so much. The gravity over here couldn't pull that 10, couldn't counteract it.
Okay.
Yeah.
Because when I did 49 minus 294, I got negative 245.
Oh yeah, let me see. Oh yeah, you're right. Jeepers, 90. Oh, let's see here. Yeah, you're right. 49 minus, I don't know what I pressed in my button there. Yeah, I got minus 245 too. So you're right, minus 245. And then let's see, I divide by 40. And I'm getting minus 6.125. Yeah, so sorry, I must have typed in wrong numbers. That can happen, unfortunately. Yeah, so I just messed up that number. Process, totally the same.